Welcome to Akshar Academy YouTube channel. In this session, I am going to discuss heat transfer. In this, problems on thermal conduction part 2. If you like this video, please subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. First one. In this question, three rods of same dimensions have thermal conductivities 3K, 2K and K. They are arranged as shown in the figure below. Then the temperature of the junction in steady state is 100 by 3 degrees centigrade, 200 by 3 degrees centigrade, 75 degrees centigrade and 50 by 3 degrees centigrade. Here we have to calculate the temperature of the junction in steady state. Let us go to the solution. Observe this figure. In figure, H1 is equals to H2 plus H3. Rate of flow of heat in the three rods. So, from figure H1 is equals to H2 plus H3. Here, this is the rate of flow of heat for the first rod and this is second rod and this is third rod. Here K1 is equals to 3K. They given as the same dimensions have thermal conductivities here 3K, 2K and K. And here K2 is equals to 2K and K3 is equals to K. Now rate of flow of in the first rod, that is K1 of theta 1 minus theta, that is equals to H2 nothing but K2 of theta minus theta 2 plus K3 of theta minus theta 3. Now in multiplying here, K1 nothing but 3K and theta 100. Now substituting K1, K2, K3 and theta 1, theta 2, theta 3 values. 2K of theta minus 50 plus K of theta minus 0. Now multiplying 3 into 100, 300. So here 3K of 100 minus theta, that is equals to 2K of theta minus 50 plus K of theta minus 0. Here K gets cancels in both sides. 3 into 100, 300 minus 3 theta, that is equals to 2 theta minus 250 is 100, K into theta minus K into, here K is gets cancelled, so only theta. Now 300 minus 100 coming this side, so 300 plus 100 is equals to 2 theta plus theta minus becomes plus 3 theta. So 400 is equals to 3 plus 2 5, 5 plus 1 6, so 6 theta. 6 theta is equals to 400 or theta is equals to 400 by 6. So 2 3 6, 2 2 is 0, 2 2 is 4, 0 0. So theta is equals to 200 by 3 degrees centigrade. So therefore final answer theta is equals to 200 by 3 degree centigrade. Okay, next we will go to the next question. Three rods of identical cross-sectional area and made from the same metal from the sides of an isosceles triangle ABC rectangle at B. The points A and B are maintained at temperatures T and root 2 into T respectively in steady state. So, assuming that only heat conduction takes place, find the temperature at point C. 3T by root 2 plus 1, T by root 2 plus 1, 3T by root 2 minus 1 and T by root 2 minus 1. See this figure, three rods of identical cross section area and made from the same metal from these sides of an isosceles triangle A, B, C. Here right angle at B. Now let us go to the solution. Rate of flow of heat in BC, that is equals to rate of flow of heat in CA. Rate of flow of heat in BC is equals to rate of flow of heat in CA. Consider here this is L length and also L. Here this hypotenuse becomes root 2 into L. This is heat rate of flow of heat in CA and this is rate of flow of heat in BC. So HBC is equals to HCA. Rate of flow of heat in BC is equals to rate of flow of heat in CA. So that is equals to Ka of root 2 into T minus theta by L, that is equals to Ka of theta minus T by root 2 into L. Here K gets cancels and A also gets cancels. The remaining is root 2 into T minus theta into root 2 is equals to, now taking cross multiplication, L gets cancels, root 2 into T minus theta into root 2, that is equals to, here the remaining word is theta minus T. Now doing multiplication, root 2 into root 2, 2T minus root 2 into theta, that is equals to theta minus T. So 2T minus T will become plus T, that is equals to theta plus root 2 into theta. 2T plus T, 3T. 3T is equals to, here taking theta as common, root 2 plus 1. So 3 theta is equals to 3T is equals to root 2 plus 1 into theta. So this implies theta is equals to 3T by root 2 plus 1. Okay. Next we will go to the next question. This question, three conducting rods of same material and cross section are as shown in figure. Temperature of A, D and C are maintained at 20 degree centigrade, 90 degree centigrade and 0 degree centigrade. So the ratio of lengths of BD and BC if there is no heat flow in AB. See this figure, three conducting rods A, B, C, same material and cross section are as shown figure. Temperature of A, D and C are maintained at 20, 90 and 0. So the ratio, we have to find the ratio of lengths of BD and BC. The condition is if there is no heat flow in AB. Since there is no heat flow in AB, theta B minus theta A, that is equals to 0. So hence the rate of flow in dB, that is equals to rate of flow of heat in BC. Now, here since there is no heat flow in AB, so theta B minus theta A is equals to 0. So therefore the rate of flow of heat in dB, that is equals to rate of flow of heat in BC. So theta B is equals to theta A is equals to 20 degrees centigrade. Now rate of flow of heat in dB, that is Ka of 90 minus theta by L is equals to Ka theta minus 0 by, here this is L1 and this is L2. Ka gets cancels, so can be written as L1 by L2 is equals to 90 minus theta B by theta B. So substituting 90 minus theta B, that is equals to theta A, that is equals to 20 degrees centigrade. So 90 minus 20 by 20, 90 minus 20, 70, 70 by 20, 0, 0 gets cancelled, 7 by 2. So the ratio of lengths L1 by L2 is equals to 7 by 2. Okay. Next we will go to the next question. 6 identical conducting rods are joined as shown in figure. A and D are maintained at temperatures 200 degrees centigrade and 20 degrees centigrade respectively. The temperature of junction B will be 120 degrees centigrade, 10 degrees centigrade, 140 degrees centigrade, 80 degrees centigrade. See this figure. 6 identical conducting rods are joined in this. A and D are maintained at temperatures. A is at 200 degrees centigrade and D is at 20 degrees centigrade. We have to calculate temperature of junction B. Let us go to the solution. Here A to B, here we are taking this temperature differences. Delta theta 1 is to delta theta 2 is to delta theta 3 is equals to, here first taking rods, temperature of junction B we have to calculate. So A at 200 degree centigrade and D at 20 degree centigrade. So from A to D, here B, C are finding the temperature of junction B. Up to B here theta 1 and here theta 2. From here to here delta theta 1, and this is temperature difference delta theta 2, and here delta theta 3. Total temperature difference delta theta from A to D. Next, now we are calculating temperature differences. Delta theta 1 is to delta theta 2 is to delta theta 3, that is equals to R is to R is to R, that is equals to 1 is to 1 is to 1. So that is X is to X. Substituting delta theta is equals to delta theta 1 plus delta theta 2 plus delta theta 3. Delta theta nothing but 180, theta 1 X, theta 2 delta theta 2 also X, and delta theta 3 X. X plus X plus X, so that is equals to 3x. So 180 is equals to 3x. From this x is equals to 180 by 3. 3 ones, 3 six. So that is equals to 60 degrees. Now we will calculate delta theta 1. So that is equals to 200 minus theta b. Delta theta 1 60 degrees. So 60 is equals to 200 minus theta b. So from this theta b is equals to 200 minus 60. So 200 minus 60, 140 degrees centigrade. So this is the temperature of the junction at B, that is 140 degree centigrade. Okay, next we will go to the next question. Calculate theta 1 and theta 2 in the steady state conduction as shown in the figure below. Here, see this figure, temperature differences here, delta theta 1, delta theta 2, this is delta theta 1 and this is delta theta 2, this is delta theta 3. Now let us go to the solution. Temperature differences delta theta 1 is to delta theta 2 is to delta theta 3 is equals to the conductivities they given as K, 2K, 1.5 K. So 1 by K is to 1 by K2 is to 1 by K3. Substituting 1 by K is to 1 by K, nothing but 2K, and K3 they given us 1.5, nothing but it can be written as 3 by 2, reciprocal 2 by 3. So 2 by 3 K. Actually K3 they given us 1 by 1.5, 3 by 2 nothing but 1.5. Here 3 by 2 can be written as 2 by 3 K. Substituting now 6 is to 6 by 2 is to 6 into 2 by 3. Here 2 ones, 2 threes, 3 ones, 3 twos. Next, temperature differences delta theta 1 is to delta theta 2 is to delta theta 3 is equals to 6 is to 3 is to 4. So this can be written as 6x is to 3x is to 4x. So from this delta theta 1 is equals to 6x, delta theta 2 is equals to 3x, and delta theta 3 is equals to 4x. delta theta is equals to delta theta 1 plus delta theta 2 plus delta theta 3. That is equals to substituting value 6x plus 3x plus 4x. So delta theta is equals to 6 plus 3 9, 9 plus 4 13x. Delta theta nothing but they given the temperatures are 200 degree centigrade and 18 degrees centigrade. So the temperature difference 200 minus 18 is equals to 13x. 200 minus 18 182 is equals to 13x. So x is equals to 182 by 13, that is equals to 14 degree centigrade. Next delta theta 1 is equals to 200 minus theta 1. Theta 1 here now we are calculating. So delta theta 1 nothing but 6 into 14. We are getting here x value as 14. So that is equals to 200 minus theta 1. So theta 1 is equals to 200 minus 14 6 84. 200 minus 84 116 degree centigrade. So next delta theta 2 is equals to theta 1 minus theta 2. Delta theta 2 3 into 14, that is equals to theta 1 116, theta 2 we are calculating. So theta 2 is equals to 116 minus 14 3 is 42. So that is equals to 74 degree centigrade. So theta 1 nothing but 116 degree centigrade and theta 2 we are getting 74 degree centigrade. So theta 2 is equals to 74 degree centigrade and theta 1 is equals to 116 degree centigrade. Okay, thanks for watching this video.